Next is Robert Millikan. Robert Millikan was our first American physicist to contribute to the discovery of the atom in terms of how we know it today. He was awarded the Nobel Prize in Physics for his discoveries and his work. Again, note how everybody is a physicist at this point because the field of chemistry doesn't really exist. This is also about 13 years after J.J. Thomson made his discovery, so things in chemistry are starting to come together much more quickly now, and lots more discoveries are being made. Millikan's experiment, the oil drop experiment, is one of my favorites just because of the genius behind it. Here's a picture of what his oil drop apparatus looks like. He obviously had to build it himself. There's no way you can go to Lowe's and buy this. Like, this is something he had to contrive in his mind. He had to build it and test it. I think it's pretty remarkable to think about that. So what happened was he took a fine mist of oil and sprayed it into his apparatus. There was a small hole that the oil droplets were allowed to fall through, and as they fell, he essentially zapped them with a source of radiation, X-rays. And as he zapped them with X-rays, they had a negative charge. So I want you to think about what that means if these little oil droplets got a negative charge. So I'm just going to draw a little negative here. So if this oil droplet has a negative charge, notice that there are some charged plates also above and below it. So here's a charged plate and here's a charged plate. The plate above is charged with a positive charge and the plate below is charged with a negative charge. So the oil droplet is going to respond to the charge of these plates. So it's going to be attracted to this positive plate and repelled by this negative plate. So he could adjust the magnitude of these charged plates to see how much this oil droplet was going to fall. Was it going to fall fast? Was it going to slow down? Or was it going to be attracted to the positive plate and rise? And through these calculations, that's how he was able to measure the magnitude of the charge on the electron. So in summary, Millikan sprayed the oil droplets, he gave them a negative charge, he changed the speed of the falling drops, and in doing so he discovered not only how negative the electron was. J.J. Thomson helped us find out that it was negative, but he didn't have a numerical value of exactly how negative it was. Millikan was able to put a number on that, and he was able to see how heavy the electron was as well. You don't have to know these numbers at all, but I do want you to notice in terms of the charge of the electron and its mass, look at how small they are. For the charge of the electron, this is times 10 to the negative 19th coulombs, which is a unit for measuring charge. For the mass of the electron is times 10 to the negative 28th. So this is a very small negative charge, it's in an even smaller mass. So the electron is incredibly small, and we have Robert Millikan to thank for that.